Hello, this is Susan Nash, and I'm going to give a little presentation today, basically because I'm so excited about what we have in store in January in 2019 in Houston. AAPG has two cool workshops. One is on how to use Python for machine learning. It's basically a Python coding workshop that's specifically for E&P. Exploration and production. And then after that we have a 2-day geosciences technology workshop that's all about machine learning in boosting reserves and also optimizing operations using machine learning, deep learning, other kinds of analytics. But before I get into that, I just wanted to talk a little bit about the basics of big data, deep learning, and artificial intelligence, potentially not in that order, but basically artificial intelligence, and how useful it is to be able to use it. And that you don't really have to be in a large company, and you don't have to have a very, very expensive plan, that there are many ways to find sweet spots, to evaluate your operations, to evaluate production, optimize, do well planning, all kinds of things, even supply chain types of planning for using AI. It's just perfect for many different applications, and it's getting easier and easier, safer and safer, but at the same time, it's changing all the time. So here's just a quick introduction to some of the basic concepts. So let's just look at big data and deep learning today. First of all, big data allows you, using big data, you can now store, access, and process data across a wide spectrum of possibilities. And so instead of having to be on-premise, you can actually be cloud-based and distributed with assurance of backups, and also that that there won't be data breaches, or at least that there's security, and potentially that, say, Amazon Web Services security will be even better than something you might have in-premise. Also, you have instantaneous access at a low cost. Oh, excuse the background noise. Somebody's drilling in a different floor, and it's like next door. You can model for monitoring and decision making, and you can incorporate a wide array of data. You can tackle new kinds of business problems, and these are things we all know, but it's just good to keep them in mind. So let's think about how we can use big data. Use it to evaluate acreage, rank prospects, basically more accurately process seismic, identify sweet spots. You can use it for reservoir characterization, using unique blends of data for deeper understanding, identify opportunities for botched shale plays or botched EOR by being able to analyze massive data sets. And essentially, you can use the big data in conjunction with tools like AI, but you don't necessarily have to use AI. You can just use basic statistical methods, cluster analysis, or neural networks, which can be, that can be AI, but they don't have to be. But essentially, let's go forward. So examples of deep learning, you could do things like direct hydrocarbon indicators with much more complexity, integrate surface as well as subsurface data, outcrop data with sequence stratigraphy, etc. You can have smart systems, not just for drilling, but also for production. Have a responsive pump that learns how to best optimize production from numerous sensors, the high performance history and history matching. This would mean something about Internet of Things or Industrial Internet of Things, where you'd have use the information that's coming in all the time to feed data to the algorithm. So you could have probabilistic rot type classification. This is something that Paradigm does, generate probabilistic, or this is now called Emerson, probabilistic facies volumes calibrated to facies logs, integrate QC steps at wells to validate neural network training. It can enable high-resolution facies results and good reservoir heterogeneity matching. So pretty exciting stuff, and you don't have to do it yourself. You can use the services of a company that's dedicated to doing this. So first of all, find and store data, big data. Well, you could use Apache Hadoop, highly recommended, wide adoption, it's flexible. And companies that can help you with storage, Dell EMC, Intel's Nirvana, also Amazon Web Services, and also Google. Big data and upstream exploration help you make good decisions quickly, and you can develop your own prospectivity indices, your own sweet spot identification, special secret sauce, whatever, and risk assessment. You can also develop your own visualization, understanding the options and relationships in new ways. So what is big data? So we look at the different things. You started out with just volume, velocity, variety, veracity. Now it needs to have value, virtual, variable. So we have different kinds of aspects of big data. So in the variety, you have structured, semi-structured, unstructured. In veracity, you could have untrusted, uncleansed. Just point of fact, data cleaning is a big, big deal. So if you can develop an effective way to have reliable, verifiable, clean data, you're in good shape. Velocity is like the rate of analysis, for example. And then the volume is obviously massive. It depends on active and passive sensors. You could have logs, events. You could have printed that you scan into data sets, social media, traditional, clickstream, this on and on. So what is structured data? It's digital. You can usually find it in a database. But what's unstructured? It tends to be like text, images, audio, video. It's something you find in the wild. So unstructured in oil and gas exploration and production, it's basically data that's not in a structured relational database. So one of the big things that's going on now, a huge opportunity, is turning unstructured into structured. Now, GPS, satellite images, those are all sensor data. Those are all, they're all digital, but they need to be structured in such a way that they can be processed. So it's just interesting. So massive, massive amounts of data. So the first step, after you identify your data, which is step 1, step 2, you make the data usable. So there are different ways, there are different approaches. Lots of companies have specialized in converting unstructured to structured. And so instead of scanning and taking 40,000 man-hours or 2 weeks, they can do it in like 2 weeks. So it's interesting to see where the data is growing, and it's mainly in unstructured. So it's a little bit scary. We're drowning in data. So what kind of data do you want to include? All of it? Some of it? None? And another big question as you start to look at your data, what will relating completely different types of data potentially reveal to you? Then, access and consume data. How? You can use workbenches, platforms, environments, Hortonworks, Hortonworks has a Hadoop sandbox, which is pretty useful if you want to really get into managing big data yourself. And so here we see a diagram that describes how it works. So it's a distributed file system. It's a data storage program. It's just one of many types. Hortonworks puts all the structured data into Hadoop, and they're basically open source. So, but they have like different libraries of applications in their GitHub site. So you have Hortonworks, Cloudera, other types, and they all work to organize your data in different ways. So then you build algorithms. You can build your own, use custom applications. You have to determine which language you want to use. Python is big, so deep learning modules, you can get them for free, or you can use tools provided by companies. There are a number of open source frameworks. Open Earth Community, it's a scalable development environment. TensorFlow allows you to develop neural networks using flow graphs. And then you've got Microsoft Cognitive Toolkit. These are just a few. So what are companies doing now? Well, they're doing everything we talked about before, apply to real-life issues. So if you want to see how to get started and how people are essentially classifying well logs, finding meaningful relationships, and coming up with cluster analyses, you can look at outstanding master's thesis, and it's open source, open access. It's getting its machine learning applications to geophysical data analysis. Brian Brower. So essentially, what are we talking about when we say supervised learning? Supervised is like we teach the desired behavior with labeled data. Unsupervised is when you don't know what you have yet, but you just want to see how the stuff stacks out. And then reinforcement learning is a way to build an algorithm that teaches autonomous agents how to behave like self-driving cars. In product, deep learning could have, a good example is facial identification, facial recognition. You could think of face as anything. It could be your productive sweet spot. So unsupervised learning helps you detect anomalies. It's also used in social network analysis, etc. Supervised learning is helpful in classifying and building predictive models. So here's a deep learning workflow. I'm just going to race through here. Implementing the deep learning. This is just one example using Nirvana hardware, but you can use it, use different hosting services and platforms and frameworks. So it's good to know that Seismic's been using neural networks for a long time. But in the past, it was really constrained by computational speed and access and things like that. Excuse me. The applications for deep learning have been around for a while. I'm losing my voice, so I'm going to quickly go through this. So let's look at real-time analysis, auto-detecting faults, collaborative workbench. So anyway, I just wanted to look at some of the other things, like you can use it for production, completion, selecting proppants, smart oil-fueled chemicals, and I've raced through this, but this is just to get you started, and I want to encourage you to come to the workshop in January and find out exactly how people are applying machine learning and how you can get involved yourself, and it doesn't have to be expensive. You can do it for almost free.